Okay, I just share my screen. Yeah, hope you are all able to see my screen, right? So just recalling the session for yesterday, what we have discussed. So here, what is the big data and Hadoop that we have discussed yesterday, and what are the layers available and the difference between. We can go with the slides one by one. So get some more ideas. Okay, so history of the databases, where we are using the databases and why we need to move to the big data platform, especially in Hadoop that we have discussed yesterday. A roadmap of history that also we have discussed, and then the difference between the GFS file system and the Hadoop file system for the comparison purpose we have discussed. And next will be this difference between the what is the meaning of big data and Hadoop, and what are the layers available. We just told with that the storage layer, and storage layer we just come to the storage layer parts, the daemons that yesterday we have tried to discuss that. So hope that you are all very clear. Any question in this point till now? So this is yesterday's discussion. Any question in this?
No, sir.
Sorry? All of you clear or any questions still?
No, sir.
Okay. So next we just go and discuss further things from there. So how name node and data node and secondary name node is working? What are the conditions it will be using the backend? Everything we just noticed on the. Just take this snaps. Just take a copy. Okay, this is a overview. Yeah, it will be available here. So yesterday, how it is working, the basic discussion we have started. From there, we just start again. So the most of the daemon is important to the neighbor interaction that we have discussed yesterday. Now we just start how it will be interact on the. Okay, we can go with resource management on there. Okay, so this is the data layer, how it's going to be interacted. And resource manager also another name is called a job tracker. Job tracker name comes from Hadoop 1x version. But resource manager they have modified after Hadoop 2x version. The reason behind the resource manager just managing the resources, it will not be doing anything beyond it. It will come under to yarn analysis. Yarn only giving the resource everything. This is it another resource management. Okay, so that is the short name of each letter of first letter. It will be a combination of yarn. So this is will be taking care of the resource management. In this yarn, only that resource manager and node manager will come. So resource manager is nothing but it's just following all the jobs like job tracker, but the resource availability, everything will be monitored by yarn. It's a one of the part of yarn. That's it. So where it will be available, the resource manager also will be available in name node itself, and it will be controlled from here to your other nodes. So here your RM, I just mentioned shortly, as a RM is resource manager. It will be available. This is going to control your all your data nodes one by one. For each data node, they will be installed that control module. That name is called as node manager. So each data node we have node manager. Okay, for the expanding purpose, you can take here in separate. Okay, so here we can take one other understanding purpose. This is the one node manager. Let's say we can consider. both will be in same color. So this is node manager. Inside the node manager, we have the control ability like application master and container. Okay, this is called application master. Sorry, this is a container. In this container, application master will be working. So container is nothing but just allocating the resource for the particular job. So one job have many tasks. So each task is need to complete from the each data node. There, the node manager will be taking that task via this container and application master. This allocation purpose, everything intermediate layer of yarn will be taken care of. Here only the yarn will be available. Okay, this is or we can mention separate. So how much resources needed for the particular job that we can validate, and based on that we can allocate the resource via yarn to our node manager. So from node manager, that node manager will be reserved some area based on that memory as well as core. So the memory allocation we are calling as a container, and the core allocation we are calling as an application master. That's it. So it will be taking that responsibility to reserve the area to all analysis with your data and send back your output to other nodes. If it is a shorter suppling is available, it will be sent back to another node. So this job, if suppose any task is going to be failure, this job can be monitored and it will be failed. All the task is completed, then only it will be considered as a job completed. Otherwise, job is not succeeded, it will be in fail. You will see some states like in that real-time UAV monitor. I can show you how we can see these things. Okay, there we can see if the job is completed, job completed. Otherwise, that status will be modified. While especially in Spark submission, you can see it will be allocated to accepted state to running state only. Then it will go to the complete, which means first it's an allocate statement. It just accept your jobs entirely, but we don't have particular resource to submit your job. Once the job is submitted, the proper resources are allocated for your job, then only your Spark job is going to be running. So you cannot make any calculation before running state. Okay, always it will be in allocate state. You will not be considered the timing. When it comes to running state, then only you can consider the time stop. How long the time job will be taking. That all we can identify. That yarn log analysis we can do based on the application ID. So each, yeah. Just a minute. Yeah, please go ahead. Any question you can raise it. This is an interactive session. You can unmute yourself and you can ask your question. Am I audible clearly or my voice is breaking still? All of you?
Hello, yeah, Dinesh, Santosh here.
Yeah, please.
Hello.
Yeah, please. My voice is clear or still
You are
very?
saying some container. It means. Hello, are
Yeah.
you able to hear me, Dinesh?
Yes, I can hear you. My voice is
So you
clear or it will
are,
be noisy?
no,
Okay, please go ahead. Yeah, Santosh, please go ahead.
so you are saying something container. So what is the container? Container, it means some any instance or any specific container.
It's
So
not a
I didn't
Docker
get clear on
container.
that area.
Just a reserved area. It's called as a container. That's it. Docker, we have a container images. We can convert as a container that we can use it. Here, the container means it's not a images. It's some reserved some memory spaces. That's it.
Oh, okay, okay.
Okay. Okay. So the meaning of container, there is a lot of the meanings available. It just reserves some memory.
Okay.
let's say example, if suppose you have a data that you're going to analyze via your Hadoop cluster, the data size should be okay. We can consider as a 1 GB of data that you're going to handle it. 1 GB of data that you are going to store somewhere, that particular record I'm receiving as a request from client. Okay, we can consider like this. So 1 GB of abc.txt, some file is available. That is, I'm going to process it via name node. Name node can identify where this abc.txt file is available. The path will be monitored because it's a distributed. So name node can refer and give you some suggestions. You can get data node 1 for first of 256 MB of data, and data node 2, you can collect 512 MB of data, and data node 3, you can collect 256, right? MB of data. So this is a 3. Additionally, it will be monitor and providing you the information about replications, where the data will be replicated. If it is data node 1, and if that rest of the data node will, sorry, that replication data of 256 MB will be combined and collapsed between this multiple data nodes. So data node 2 and data node 4 have the replica data. Okay, this is the replica information. Okay, so likewise, each node, it will be represent and give you that information to you. Based on that, you can start an analysis. Okay, so this information, once you collect it, then this will be come to your yarn. Okay, so next, you have metadata information clearly from name node. This 1 GB we can get from here and we can start the job. Then this will be reached into yarn. Okay, sorry. From yarn, you can get all the proper information, how much resources needed for the particular job. So this is only 1 GB of data. So this resource is needed, 1 GB of space memory you need. And for 1 GB of data, you can handle via only 2 core or 1 core is more enough. So yarn can consider and create one application ID as a job ID. So it will be create like application underscore ID 1, 2, 3, 4, 5, 6 something. It will be create one ID. So in this ID, it will be reserve the area for 1 GB space is needed, and 2 core we can give it for this task. Like that, yarn can consider, and this information finally will be transferred to resource manager. Okay, so this information will be transferred to the resource manager with this job ID. Okay, so now resource manager know I have one job which is request with 1 GB of RAM and 250, sorry, 2 core we need to run with that job. Like that, resource manager can be identified, and reserved area will also yarn can understand 1 GB we have space. Now this data we have resource manager, right? It will not be allocated entirely here based on your application and the data node availability. 256 MB of container will be created in data node 1. Here just 256 MB to analyze your task. Here another one will be allocated with the data node 2 available with the 512 MB of data. Okay, so here it will be 512 MB. You can consider like this. I just collect other color. So this job will be 256 will be running here. Data node 2 with the 512 MB of data will be running. So here only the container can allocate with the 2 core, 1 core will be running here. Another core will be running here. Data node 3 also will be running. Likewise, the job will be split and will be start the operation. Okay, once all the job properly completed, job has completed like that, resource manager respond back to yarn. Otherwise, job is not completed or task is without proper resource, we cannot complete the job. All the information resource manager will be gathered and we find it will be sent to yarn with failed status. Okay, like that only in the backend it will be followed. Are you clear? Any question in this point? This is the way processing layer will be happen in the back. Any question in this? Hope no question. Okay, so next we can go one by one. For each task, that is the meaning for container, and then application master. Application master is nothing but it will be reserved some memory, sorry, ports. For understanding, I just simply mentioning also some core detail. Okay. So yarn also we have discussed. Actual size allocation for each job by yarn and transferred to resource manager. That is a yarn work. Okay, so yarn 1, yarn 2 is available. Yarn 2, they will be increased to little more performances. Hadoop 3x yarn very fast to compare with Hadoop 2x version. It 2 times faster than Hadoop 2x, the Hadoop 3 version. So they are doing a lot of that implementation and that performance tuning internally by themselves. While you're starting with Hadoop 3, internal performance tuning they are doing by themselves. Because you have to do before, but now it's not required. They are doing. Okay, so next yarn and resource manager will be reached. Resource manager will be monitor all the job. All the job and find out the status. That is the use of resource manager. So node manager is nothing but this is already following with the task. So one job available, multiple tasks. Let's say for example, I have table, employee table and accounts table. I am going to join and find out the data. So first select start from table, select start from employee table, select start from account table, and then I'm going to join it. This is the backend happen. So 3 tasks is running for a single job because the joins will be between the 2 tables, then only we can get the final output. So one task will be a single query, but internally it will be running with 3 tasks. So this 3 tasks is completed, then only that one job is completed. Like that, then all the monitor will be taken care by resource manager. Each task monitor will be taken care by your node manager. Completion. Okay, a node manager inside container. Okay, based on container and application master. Okay, so now we have some idea about application master and container and resource manager and node manager. Okay, so now we just come back to block report. Before go to the block report, we just discuss about block sizes because we must know what is block sizes, then we can discuss about block report. So block size is nothing but whatever the data you're going to store it, right? That will be by default allocation with some sizes of your data. Anybody know how much the block size of your Windows OS and Linux OS? Anybody notice that?
It is a 4 KB.
Sorry?
4 KB, right?
Which one?
Block size.
Yes, which one? Windows or
Linux,
Linux?
Linux, Linux.
Okay, what about Windows?
Windows, I don't know.
Okay, so Windows is a 128 or 64 KB, but Linux is not a 4 KB. I think 4 MB size. I'm not sure. Anyhow, we will check. But 4 is a number, I'm sure, but is a 4 KB or MB? I heard about 4 MB only for block size. Okay. So here in Hadoop also they'll be following with 128 MB block size. Why we are considering the block size? Any idea about it? What is the use of block sizes?
It's like splitting the data into the.
Yeah, that is how it will be splitting it. Okay, by storing the data in your system, in your hardware, sorry, that hard disk where that place, it will be keep on monitored with your OS operating system. Then the blocks will be identified and split by chunks of your data. Then only the processor efficiently going to fetch those data and process it. Let's say example the same, like you can consider as a one okay, you'll be watching some videos, right? 100 MB or 200 MB of 750 MB of your video size is available. That is look like as a single video, but inside the single video file split into multiple blocks. Because whenever you're going to run that your video in the back end, what is happening, it will be sliced based on the chunks of data. Each chunk will be transferred to your processor. Processor will be reflected to you in the display dashboard as a monitor. So like that, it will be. That's the reason we just using the blocks will be splitting and make some fast analysis. Otherwise, what will happen? Chunks of data we cannot split it properly. It takes long time. You have only for 4 GB of RAM in your system or 8 GB of RAM only you have in your system. If suppose all the data will be moved to the memory, you cannot do multitasking. So those kind of operation you want to do such more, then you want to slice your data. So block sizes help to chunk your data, that part. It will be splitting your data into multiple size of multiple pieces, and it will transfer one by one to memory and process it. Once it is over, then only you can see rest of the data will be moved to memory. Okay, you can realize that just imagine with your real time. Few of the places you can see you will be open some video, you can immediately forward, you cannot analysis first. First it will be showing your video with blur and black color, and then it will become to your actual color. Because graphics analysis process, everything will be taking some time. So come to point here. So block size, like here also, all the data will be split based on that 128 MB. A 128 MB, why we are splitting like this? The reason behind, we are not only using for single node mission. We are combined and using for multi-node cluster. So, and also while storing the data, it will be split multiple places. So whenever you're doing the analysis, this chunks of data will be transferred and do analysis in top of this size of the memory. Okay, based on the block sizes only you can store all your data. In Hadoop 1x version is a 64 MB of data. Hadoop 2x version and 3x version, both they are following with 128 MB by default. Okay.
This can be configurable as per need, right? So this is the default block
This
size.
is a default. If you want, you can change it.
Yes, we can change like during the placement of the data, we can configure it.
While you are inserting the data itself, you can configure at runtime command based. That are will be seeing that hands-on sessions. How we can change the block sizes while storing that. Also replication also you can modify it while inject into your Hadoop environment.
Okay.
So once it is inserted, then also you can modify the block sizes as well as replication. Okay, everything is possible, but by default they are suggesting to go with 128 MB. But if you know your data very secure and very important, then you can go with the file replication, then okay. And you can convert those data with 128 MB to 512 MB or 64 MB, everything is possible. That depends on your data. Okay,
Maximum
why
size.
yeah.
Sorry for interruption. Maximum size is 512 MB, or more than that we can
No, you can change into 1 GB also.
1 GB also.
Okay, that's not as one part. You can change into 10 GB also block size. You can do it. Whatever you'll be providing that command based, you can. What it will be considered inside while storing the data, it will allocate the block size. It's not much. But mainly they are suggesting to load your data with big files into your Hadoop with 128 MB of sizes only, with block size. The reason behind, if you suppose you're going to write your data with 10 GB of data into Hadoop environment with 128 MB sizes, it equally will be distributed as well. Your chunks of data will be equally available. All the node efficiently will be managed with your data. If suppose you will create those data as a single block, then you cannot perform more. That's the reason we just slice it. Okay, later what we can discuss about report split and block size. There you can get some comparison. We will discuss later sometime. Okay, till now any question?
Oh,
Okay. So now we just come back to block report. So block size, we know how the data will be stored into our environment. So based on the block size only, the block report will be transferred. Where this block report will be transferred? It will be transferred from each data node to name node. Okay. So from each data node to name node, where the data is available, what are the block will be allocated, all the information will be gathered and will be transferred. So each data node will be transferred from, okay, everything will be coming here. I just declare like this. So this is called as block report.
every 3 seconds it will send the information to
That is a heartbeat.
heartbeat process.
Okay.
Block report is 30 minutes or 10 minutes or 1 hour.
It will be following with 5 minutes of once. Just as a block report, what are the blocks is available, how much
On the
block will be completed, what kind of chunk will be used, that information will be transferred. Okay.
okay.
Any other question?
No.
Okay, so this is the use of block report. So inside the block size 128 MB, so how many blocks will be locked and how much space is available, all the information will be transferred via block report to name node. So based on that, name node can consider, okay, these are all the data nodes available still with this much of utilization spaces. Like that, it will be considered, and new data, whenever it will be transferred, it will be trying to insert into that particular data node. It's like a reserved area. Okay, it's not a reserved area. It will be distributed based on your utilization. Suppose data node 1, 80% is completed. Data node 2, 25% only completed. Data node 3 and 4, just 10%. Then name node will give the preference to data node 3 and 4. But that internal algorithm, we cannot measure it. But that's the way, because it's already heavy loaded, then equally the data will not be distributed. So name node will be considered and will be distributed to other data node on time.
It's in
Likewise,
based on the availability only, it will segregate like transfer data.
not it's not like a availability. Utilization is a internal concept is called a block scanner is available. That block scanner will, based on that it will be identified. Hadoop 3 they are calling as a block scanner. Hadoop 2, Hadoop 3 they will be calling intra data loader like that.
So block
Okay.
scanner will be maintained by the like it will be maintained by the name node or zookeeper.
That will be controlled by block scanner will be controlled by each data node, because it's internally identifying how much block will be allocated and how much the space is available. Everything will be considered by an internal data node. Okay.
Okay.
So that's also one of the improvement they have done in Hadoop 3. That concept we can see in something. Okay.
So in between, like any specific block has been corrected, or in those cases, like how this specific block report is maintained, like on what basis this block will be transferred.
Come again. If in between the data node,
Actually,
I cannot understand that clearly.
sorry, actually, the exact question is like, for example, from each and every data node, like this blah 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 block report will send to the name node, correct? So the block report will contain the what are the blocks is already available on the specific data node. So in
Yeah,
between,
correct.
any specific blocks, for example, data node one has 10. Data node one has 5 blocks in the sense, like in between any one of the block has been captured in the sense. So on those scenarios, like how it will identify and what are the precautions it will take from the name node perspective. Like
Okay, as per my understanding, you are asking about fault tolerance here. Am I right? Or
yeah,
something different?
yeah.
So yeah, okay. So that will be followed here. Once the data will be stored in your data node, in case it's going down or failure, the data node will be, while insert the data, immediately it will be following the replication factor. So other data node should have the data immediately. It will not take time. Okay, whenever the data that you are going to insert into data node 1, that block will be completed. Let's say example, we can consider 1 GB of data that you are going to store to data node 1, 2, and 3 with 256, 512, and 256 MB. We just consider the above one, okay? Just for the understanding, I just copy this. Oh, sorry.
It's not a complete fault tolerance. I'm just saying like exact specific block.
Yeah, I will come to the point. For understanding is very important, right?
Yeah.
I will come to the point one day. So this is, you may consider two block. Okay, because 128 MB, so 2 block will be allocated.
Yeah. Okay.
This is a 4 block, right?
Yeah. After 128.
And this is a 2 blocks. Okay, so while insert your 1 GB of data, it will be sliced and it will be stored like 2 block, 4 block, 2 block, like this only. So first block will be right into data node 1. It will not be wait until second block is completed. Immediately data block, that block 1 will be replicated to any other data nodes. Like we have noticed somewhere, right? Replica will be available data node 2 and 4.
Rack
So
awareness.
first block will be
So based
completed.
on rack awareness, it will based.
Yes, exactly. That will be following the backend. Rack awareness will be taken care of because all that Hadoop cluster that we are going to create based on the rack server, they are also suggested to go with the rack server. Okay, there that hard disk everything will be followed and will be transferred. So first block is completed immediately. That it will not be wait. This data will be transferred to other data nodes. So data node 1 will be 256 will be available with data node 2 and 4. So first block will be write, immediately will be replicated into this one. As well, the same block will be replicated into data node 4. Likewise, the data will be replicated. Whatever the second block is written, it will not be wait. Okay, like that, it will be continuously following. If suppose while writing itself, your data node is going to be failed or down, then your data will not be properly written to your data node. Immediately, name node can consider something is going wrong with your data node. Immediately, it will transfer your all the particular data allocation and the data insertion with other data node. Okay, because it's a part of task completion only, but it's not completed yet. So it can be understand. It will be transfer all the operation with other data node. Like that, it will be following that awareness in the back. Okay.
Okay.
Any other question?
No. Not right now.
Okay. So now we just come back this one block report. We know very well. Now we just discuss about block report. Okay, everything's over. Then we can discuss about edit log. Edit log is nothing but that information you are transferring to block report, right? This edit log is a recent changes one will be transferred.
Editing progress. Correct.
Sorry.
No, this edit log will be saved in the edit in progress file, correct? Edit in progress.
Voice is breaking, sir. I'm sorry.
No, sorry. No, actually, I'm just saying like this edit log will be saved under the edit in progress file, correct? Edit in
Yes,
progress.
exactly. What are the changes that you have done? Okay, let's say, for example, you write the data with one directory and you want to change the directory name to a different name.
So whatever the changes we perform in the HDFS, like all the information will be tracked in the edit in progress file, like
yes,
access,
exactly.
permission, like any, like for example, make directory or removing the directory and inserting the file. So this kind of information will be placed under the edit in progress.
Exactly. You can store the data, you can modify it, you can delete the data also. But how it knows by name node? Everything will be monitored and considered from edit log. It will internally edit log will be noticed some recent code something based on that it can be understood whether the particular that folder is available or not. Like that, it will be considered via this edit log only. It's like a log. Okay, the recent changes of all data nodes, all data. Okay.
Okay, it will keeps on grow, correct? So certain point of time we need to do housekeeping, like we need to transfer that to the secondary name node, and we need to get to the
So this kind of
While you're doing expunge at the time, edit log, the old data will be removed. Okay, that is happen in the backend. Also, disk cleaner, something is available. Based on that, we can do that. Intra disk cleaner and something. Based on that, we can release that old edit log and only the recent changes we can store it. Because already it will be captured. Okay, via we can achieve it. So next point we are going to discuss input split. So input split is nothing but block size is a physical layer of storage.
FS image or any topic of FS image, file image.
Yeah, that will come in. We just mentioned, right? I just go with comparison. I just listed everything, major important demons, but I just go the comparison list on there.
Sorry, actually, I just thought like since this edit in progress topic came, like because like each and every year, like the FS image and edit in progress file will get merged, right? For the
Come again, a little noisy. I'm so sorry.
sorry for the interruption, everyone. Like so the reason I've asked about the FS images, like since this edit in progress, like so this topic came, right? So
Yeah,
each and every 1 hour, like this FS image and edit in progress will get merged, so that only this and name node will have the updated information, in his memory, right? So that only I just pulled the topic
yeah,
of FS
okay,
image.
correct. Okay, I agree with your point, right? Based on that edit log only first image will be generated. That is only recent data only will be stored because all other information already communicated and only the recent changes of edit log information will be captured as a snapshot and will be transferred from name node to secondary name in case of name node down. Otherwise, FS images will not be used anywhere. Okay,
Yes.
based on
And one more thing,
edit log.
people who are attending these trainings, please don't mistake me. I'm just asking these many questions. So if you have any questions, you can ask here. So don't mistake me. Okay.
No
Thanks.
problem. No problem. You can go ahead. That is, it's what I just mentioned. The meeting name as an interactive session. Okay. You don't worry about it. You can raise any question. Even I am wrong, you can mention. That's not a problem. Okay.
Thanks.
So till now we have discussed. So there's 20 events available. We have discussed. Okay. So now we just come to input split. Input split is based on the block size. It will be converted as a mappers. So that mapper will be converted from input split to based on the input split only. So number of mapper equal to number of input split. That is the base concept. How the input split will be generated that we can see now. So like that I mentioned, right? 256 MB of data. If suppose the data sequentially will be stored between the blocks, then it will be considered this two will be okay. We can take this one. This 1 GB first data node 1 available with 256 MB, right? So here one is available. This is one, and this is the second block of your data. So total 256 available. So this kind of, if the sequence data will be stored internally into name node, this will be considered as a single input split. Okay. Both will be considered and create as a only one input split. Why it is creating like this? Based on the input split, the number of map will be running. Okay, so now if it is going, I'm going to start my job where this resource manager to task. This time the task will not be considered two tasks for this project. Because both will be following with the same, right? So sorry, same task with number of mappers. Here it will not be considered as a two mapper because the same task we have, same data we are going to handle it. Then it will be considered and create as a one input split. Why it is doing like this in the back end? That will be following the number of mapper will be acting with your application master. So how many mappers available at the time that application master going to process based on the mappers only. So if suppose it will be considered as a single mapper, then your application master also, while transfer your data from data node to that container place or reserved area, that entire data will be transferred. So your performance will get little more to compare with each data analysis. So that is the use of input split will be used in the backend. Okay, it's little difficult concept. If you're not clear, let me know. I can tell you again.
Mapper will read the data each and every line, right? On the each and every line, and
Mapper?
Oh, so the map reduce concept is like like HDFS is like to store the data, and map reduce is for the processing whatever the data in which is stored in the HDFS.
Yes,
So
exactly.
so my question is like how mapper will read the data, like it will read the data each and every line, like how it will be, how this input split will be calculated.
Okay, so how the mapper will be reading the data? That is you're asking, right?
Yes, how it works, that is my
Okay,
question.
come to this. So this is the same. You just compare. I just moved this value here. First block is 128 MB. Okay, second block also 128 MB. Two blocks will be covered with your data. Then mapper going to pick up your data based on that key value balance side. Because whatever the data you're going to analyze it in Hadoop platform, everything you'll be going to identify where is the key is available. Based on the key only you can do analysis. Okay, just retransfer and you can start your operation with the mapper. You know the concept about the mapper, I guess, right? So
Yes,
everything will be considered as a key and value.
key value pair.
So if suppose I'm going to do word count, we just consider in this file all the record we have stored as a words, right? Based on the spread we just sliced and then we can start our operation. So each word it will be considered as a key, and each word first time we can assign as a one value. And then mapper internally the chart and shuffling will be happen, and that data aggregation, everything we are trying to do that. So each data node itself it will be considered and creating the word of total values. Okay, you just think and consider about that. What count? Oh, 1 minute.
Yes,
I
I
have
understand the
slides.
concept.
Okay. I don't have that slide. So it's like a burger concept. They'll be using this map tool that you said, how the burger is created. I missed that slide. That's very easy and very simplified about the map reduce concept. Okay. Likewise, the map and reduce, but it will be depends your block sizes only. In Hadoop, if you come internally, the mapper will be created based on the block sizes only. That block size also we can shortlist it and you can do the performance via input split. So in the architecture, the backend mapper will be follow with input split follow with your block size. That is the way it will be happen in the back. Okay, this is the flow.
Okay, thanks.
I can mention like this. That is the correct one. Okay. So till now you have some idea about it, right? We can go and discuss about this also. Map and reduce the following with programming based data processing only, because map algorithm we have some in dictionary also. Everything will be followed with map and reduce only. Map and reduce process only. And then input split, short and shuffling. We can transfer the data between this one node to another node. That is called the short and shuffling. It's called another name with intermediate value also. But while transferring the data between the node, we can follow with short and shuffling. So mostly you want to doing that any data changes at the time, always short and shuffling will happen in the back. Okay, we can see in real-time hands on the session. Next, resource manager. Till now, we have discussed this point only. So resource manager, how it is working, that is also we have discussed. In resource manager, we'll be following with resource manager and node manager, container and application master. Okay, hope you have an idea about this one, right? Till now. Any question in this point?
I don't have any.
Okay, so default replication 3x. Okay, but you can override, that is also possible. Fault tolerance will be following with replication, high availability. Okay, both will be taken care. For the name node will be followed with high availability and replication factor for data node analysis, and network communication, everything will be followed with intra algorithm. And yarn, FS images, zookeeper, erasure encoding. Erasure encoding will be introduced in Hadoop 3 expression. Okay, instead of replications. Okay, so we don't want to waste your spaces, because in replication, if suppose 1 GB of data will be stored into 3 times then 3x, then 3 GB of data, you want to lose the spaces, right? That is a waste of your storage layer that will be reduced by erasure encoding. In erasure encoding, they are using 3 concepts that later point we can discuss much. Okay, so next we are come to this one, resource management and ecosystem. What is ecosystem? That is also few of them will be confused. That all the process with Hadoop, on top of that you can do the processing via MapReduce in the backend. Directly will not be used in the backend, only you are using this MapReduce operation. So that all will come to ecosystem. So data ingestion you can achieve via Scoop for batch processing. Real time you can transfer your data via Kafka and Flow. Data analysis you can use Hive, Spark. Pig is an old tool nowadays. Nobody is using that. So majorly it will be used Hive and Spark. And this is the only tool not like that. We have multiple tools also will be integrated with Hadoop and all. But majorly we are using for Hive and Spark. And NiFi is available. Other tools also will be available. Everything will be following with analysis purpose. And data exploration and management, Ambari is available, Q is available, Cloud Raw Manager. 3 will be following with management purpose, where the data node is going down, and if suppose any memory filled or resource will not be available, all the information immediately we can track via this management tools. Next, workflow. So scheduling part is very important. So in this scheduling part, Woozy, Airflow, Control M, Autosys, this kind of tool is available. In our session, we are going to discuss about Airflow majorly. Okay, on column-based analysis.
Autosys or job scheduling tool, right? Job scheduling.
Yes, exactly. Crontab also is job scheduling tool. Okay. And column-based analysis, HBase, Cassandra, and MongoDB, a lot of things is available. Only you want to do analysis with your column-based analysis. But ecosystem, HBase only come to as an ecosystem for Hadoop. So we are going to discuss HBase. Additionally, Cassandra also nowadays very big. So Cassandra also we are going to discuss in our session part. Okay, I just mentioned everything in our course overview. Next, I just come to the difference between the Hadoop 2x and 3 expressions. So what are the differences available that we are going to discuss now? So first, Java version. So Java 7 only will be support in Hadoop 2x, but Hadoop 2x is a minimum Java version is JVM 8. Okay, so once you have Java 8, then only you can handle via Hadoop 3x. So, and fault tolerance, they are following here with replication 3x factor, but in Hadoop 3x, they modified it and moved into erasure encoding concept. And storage space, based on the replication data, you can lose your storage with 200% override, but via erasure encoding, you can lose only 50%. So you can compare, you want 50% of your storage, you can use it for each data validation. So it's minimize your sizing value and efficiently you can handle your data. Okay, so that is
Sir,
a major
Arindam,
yeah.
sorry for interrupting. So this is Arindam. Actually, I wanted to know one thing. In the Hadoop, right, the main languages are Java, Scala, and Python, right? So is it still like previously Scala was the preferred language? It used to be faster with the Java because everything is written in Scala. But
Yes,
is it the case now also that
hmm.
is it the case now also that Python is a little slower than the Scala because now that Catalyst and all that has come into picture, right? So that I wanted to know.
Yeah, okay, so you said I agree. Python is little slower, but it's bit slow, not much. Okay, first, but integration process with Python you have, and as a data engineer, you're not only focusing based on the Java or Scala. You'll be going to analyze. This is a tool. Okay, this tool you're going to interact with some other way also. So that is the way you can use Python. Python have n number of community support as well. It will be interact with your Hadoop environment or other places also. The correlations is available. But in Java and Scala, few of them is not available. Okay. But efficiency wise, I agree. Scala because Spark job, Spark that tool will be generated via Scala itself. But once, if suppose you are only depends with the Spark, you can go with Scala. Apart from other tools also you want to learn, then you can go with Python is a sufficient. And that's a have great opportunity. You're not only
Yeah,
working for data engineer, you'll be going to move as a data scientist.
yeah. That is where actually my question is. Like, but in the Scala world, right? These details are not that much, right? Like the machine learning libraries are not.
Yeah, truth. It is in developing state still.
Okay,
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 but
okay.
Python is already used everywhere. Python is going on.
Yes, yes, yes,
Yeah,
yes. Okay, okay. Thanks,
that
thanks.
is a yeah, that is a major important we are giving to Python. I am a certified in Cloud RAM. I have done my certification in Scala. To be honest, I agree. But after that, I realized if I am going only for Spark, then only I can use this Scala. I didn't never used any other places apart from Spark. If suppose I'm going to do any integration, then I want to convert and learn about Java. Why I need to learn two Javas, two programming? It's not required, right? So I just plan to go. Programming is the only one is enough to improve your performance also in that. Otherwise, you want to learn both again. You may be confused somewhere. I don't like that. So that I just decide Python is enough. Only one program, I can do all the ones. To be frank.
Yes, yes, yes,
Okay.
yes, yes, sir. Okay.
Okay.
Yeah,
Any
the
other
thing
question?
is, yeah, the thing is like each and every program languages has its own pros and cons. Like so in this area, like for example, Hadoop and MapReduce, it's basically like built up by the Java. So for the Spark, like 75 percentage is like it's been built by the Scala programming language. Like the only deficiency from the Python side, like if you are using any Spark in the sense, there is a concept called a data set. So data set kind of activity we can't perform with the Python programming language. This is what I know. Correct me if I'm wrong.
Yeah, honestly, truth.
Yeah. Apart from that, like Python is known for like most of the people, like in between, if you get any stuck in between, if you're performing any kind of activity in a Python perspective, we can seek any kind of help over the around the world, like any communities. So Python will be the more best option. But in terms of Spark perspective, only in terms of Spark perspective, Scala will be the good choice from.
Yeah, you are only become a Spark developer, then Scala will suggest you for entire your lifetime. If you
Yeah,
plan to learn more than Spark or other process also in future, then I would like to suggest to go with Python. It will give you the opportunity.
and especially the
That's the
data scientist
difference.
character, like people who are seeking, like who are willing to seek the career in the data scientist,
Mm,
they need to prefer the Python is the only best option.
yeah, truth. That's 100% true. Python also, they are doing a lot of new implementations. Additionally, they have already have all many of them. Additionally, they are trying as a new. Also, Spark 3, they are majorly thinking about Python based Spark analysis. All the functionality, how efficiently we can migrate. Because all the ML algorithm in Spark in the backend, they are implemented via Python API integration only. It's called Py4j based on that. The main difference between the Scala and Python, while you convert your data, sorry, while you convert your code via Scala, directly it will be injected into a JVM and it will be performed. So those the data, sorry, the code conversion will take few seconds delay while you're using Python, because Py4j will be convert all your code from Python to Java in the backend, then only it will just execute. This code conversion will take few seconds delay. Apart from the performance wise, once it starts, both will be same, because Scala also will be converted the backend to Java. Both will be converting their source code to Java, then only it just execute. So it's not a big deal to us. Only the conversion time little slow to compare with Scala. That's it. Spark 3, just go and see about the features. You can see they are providing ML algorithm more with Python related. Directly in Spark 3, you can use Pandas UDF. That's the additional feature they have given. You don't want to develop everything in Scala or other tools. You can directly use Pandas UDF there itself. Like that, they will be developed. And 40%, they will be providing Spark SQL also. So
But
there are a
pandas
lot of
will
changes
be
they're doing.
but
Yeah.
pandas will be native to Python, right? Is it like in Scala also they are you can write pandas in the Spark or?
No, you can implement Pandas UDF in PySpark.
Oh,
That is,
okay,
I
okay, okay.
mean, PySpark, they are giving little more implementations. Whatever is not available via Scala, you can achieve everything via Python now, PySpark. Okay.
Yeah,
Any other
yes.
question?
No, not for now.
Okay. Also in Python, you can submit your job. You don't want to confuse or you don't want to do any dependency. It's like a plug and play. You can do it everything. But Scala is not like that. It takes some time, and while convert your jobs, or at the time also you'll be facing a lot of issues, dependency and a lot of things. So once you know the expert, and then only you can feel and you can go with Scala, the basics. But it's a functionality. Every year they will be modifying new functionality. You want to learn it. Python, they will be doing implementation, method implementation. So it's not a big deal to upgrade yourself. Okay, in Python 4, makes many of them expected one major changes to compare with Python 3. I'm also waiting for that. Okay, we are come out from the topic. I just come back here. So storage space we have discussed, and disk balancer in Hadoop 2x they are following with Hadoop HDFS balancer that I told you, right? In case of any data node is failure, the block is failure, the rack awareness, everything followed in HDFS. Sorry, Hadoop 2x will be in HDFS balancer, but it is in Hadoop 3x intra data node balancer will be taking care of that part. So internally, the data node find out the algorithm to validate all your data, then only it will be interacted. Otherwise, what will happen? All the data nodes will be communicate together. That time only Hadoop TX you can validate. That is the major difference they have achieved. And standby name node will be in Hadoop 2x only one. Now in Hadoop 3x you can use more than one standby name node. Okay, you know the standby name node, right? It's a active name node and passive name node, something we have discussed, right? Everything depends with your name node, only one in your Hadoop 2x. In Hadoop 3x, we can go more than one. Behind that's why they will be migrate and they will be changed into more than one name standby name node. I will tell you in a few points later. Okay. So yeah, no scalability. Whenever you submit the job, it just identify the resources. It will not be doing any particular timeline and performances. But Hadoop 3x, they are improving the job scalability and timeline. When this job is going to complete, that estimation will be provided in Hadoop 3x.
Like
They are
SLA, it will provide.
including, yes, like the SLA timing, approximately it can provide in Hadoop 3x. Then we can measure how long this job will take. That is possible in Hadoop 3. Next, port number, all the port number will be converted from 500 and 802 98 series. So if suppose you want to see the data from Hadoop 2x name node information 500, 700, you can check it out that information. But here you can check 9870 series. Okay, like that, because this is ephemeral ranges. So same application using the same port number. If suppose you are going to use Hadoop and the same system you're going to install some application depends with the same port number, you're getting error. So that they'll be uniquely designed and giving this port number to you. It's reserved for Hadoop 3. Only this port number will be used for Hadoop 3x applications. Okay. The file system will be support only for AWS FTP, and that only already they use provided. That's what AWS also little more big. And now added, they have additionally added Azure file system as well as Alibaba cloud file system. Both two file system they have included with Hadoop version, so it can easily interact with the cloud of Azure and Alibaba nowadays. Okay, that is the use of this tool. And finally, number of node up to 10,000 node only you can enable in your Hadoop 2x version. More than 10,000 it cannot possible. So 9999 number of node maximum 9999 only. But Hadoop 3x there is no limit. So this is the reason you can get standby name node also will be increased from more than one.
2x also it don't have any limit, right? Now only the Hadoop one version only up to 10,000 nodes they have tested.
No. Hadoop 2x also they will go with 10,000 nodes only. Just check it out. I also had a confusion. I just check it out. Up to 10,000 only in Hadoop 2x you can. So that limitation will be released from Hadoop 3x. So based on the number of node, you can select standby day node because it will be equally, how can I say, it's sharing their metastore information and will be following all the jobs. So that's the reason more than one standby node you can bring up in Hadoop 3x. So point number 9 will be followed with depends with point number 5. Okay.
Okay.
So I think that's it. So any question, any doubts still, if you're not clear, any point, you can let me know, we can discuss it.
So till now, most of the companies are using the Hadoop 2x version, right? So from your knowledge, like are the companies started using the 3x version, or
Yeah.
or
Yeah.
still they are testing only the 2x version?
No. They are few of the company they have migrated to 3x because they are getting some advantage via 3x, right? So they are migrated. They are doing first the validation POC with 3x, whether it is possible or not. Then they are migrated. That migration also very simple. Okay, it's not a big deal to them because they will be providing any of them while they are doing the migration. They know very well about the Hadoop 2x. So the particular Hadoop admin will be migrate the data. Okay.
Okay. The
So
point
like
is most of the
first
companies
they will be.
started.
Yes,
Sorry.
exactly. In the development environment, they will be testing properly. Then only they are migrating to Hadoop 3x. The major problem in my company while migrate from Hadoop to 3x, as of my experience, that compatibility. Few jobs is not available for Hadoop 3x related. So we just validate. So that time it was not stable. During 2018, 19 end till we don't have any stable version. And 2020, the Jan onwards, we have validated all the jobs is available, and they are also doing the development, right? So it will be migrated. Now Spark 3 is released, right? That majorly will be support with Hadoop 3x to compare with Hadoop 2x. So everybody they are making some developments with Hadoop 3x only nowadays. So within the next year, Hadoop 3 will be stable release. I hope so. Because they are getting a lot of benefits in Hadoop 3x. Am I right?
Yes. So classes will be only on weekends or?
Already weekdays batch is going, sir. So once it is done, then only we can start a new batch. So you have some idea, right? How it is going our session. This is a interactive session always. This is the way until the end it is going. Okay. I'm promising you really. So don't worry about it. And all the syllabus, everything I just already mentioned you can go through that. And interested people just ping me in WhatsApp. We can discuss.
Okay.
Okay. So you have idea about it, right? So all the syllabus, everything I just give you and I just put in front of you. Just go through with that and let me. Okay, guys, if any no question, we can close the session today and we can see by next week with paid session.
Okay. At what time? Like any specific timing?
Same time,
Same
same
4:30.
time only. Yeah. 4:30 to 6:30.
Saturday, correct? Saturday and
Both Saturday, yeah.
Okay.
Weekends.
Okay, thanks. Thank you for your time. Thanks.
Yeah, okay. Thank you all. We can discuss more. Bye.